My dear students, in the previous video, we have solved some problems to finding the limits of certain functions involving indeterminate forms using L'Hopital's rule. So in this video also, I am going to continue the problems to finding the limits of certain functions using L'Hopital's rule. Consider example number 7.37 in your textbook. If limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta is equal to 1. If it is given so, then prove that m is equal to plus or minus n. Then prove that m equal to plus or minus n. You have to prove this using L'Hopital's rule. L'Hopital's rule for finding the limits of functions. Given limit theta tends to 0, 1 minus cos n theta by 1 minus cos n theta equal to 1, then you have to prove that m equal to plus or minus n. So if you apply the limit straight away, you will get limit theta tends to 0, 1 minus cos m theta by 1 minus cos n theta. If you apply the limit for theta tends to 0, cos 0 is 1, 1 minus 1 by cos 0 is 1, 1 minus 1, you will get 0 by 0 form. It is an indeterminate form. 0 by 0 form. It is an indeterminate form. Okay. For that, you apply L'Hopital's rule. By L'Hopital's rule, you have to differentiate the numerator function and the denominator function separately with respect to theta. By L'Hopital's rule, differentiating numerator limit theta tends to 0, 1 derivative of 1 is 0. Cos m theta is, you write so once again the sum cos m theta by 1 minus cos m theta equal to, by L'Hopital's rule, limit theta tends to 0, derivative of 1 is 0, cos m theta is minus sin m theta into m, therefore minus or minus plus m sin m theta. Derivative of cos m theta is minus sin m theta, so minus or minus plus sin m theta into derivative of m theta is m you have, therefore m sin m theta. Similarly, in the denominator, derivative of cos m theta is minus sin m theta is minus or minus plus sin m theta into n, therefore n sin m theta denominator, n sin n theta. You take that m by n, m and n, numerator and denominator terms out of the limit, m by n you will get, it is out of the limit theta tends to 0, again sin n theta by cos n, sin n theta by sin n theta, sin m theta by sin n theta is again theta by 0 by 0 form, sin 0 0, cos 0, sin 0 is 0 0 by 0 form you will get. Therefore, you straight away replace limit theta tends to 0, divide numerator sin m theta by m theta. To balance it, you multiply by m. Similarly, in the denominator, you multiply sin n theta and divide by n theta, and to compensate, you multiply numerator of the denominator by n. Sin m theta by n theta into m, sin n theta by n theta into n. I am dividing both sides, numerator and denominator, by theta, and also I numerator by m and multiply by m, and denominator by n and multiply by n. So now you take that m and n to the outside of the limit, you will get m square by n square, limit theta tends to 0, sin m theta by m theta, denominator is sin n theta by n theta. This is your problem. Sin m theta by m theta and sin n theta by n theta. You take that m square and m and into m square and n square is numerator and denominator. You will take m and n. Out of the limit you will get m square by n square. I rewrite the problem once again. To understand that, I rewrite this step once again. This is equal to m square by n square limit theta tends to 0 sin m theta by m theta denominator sin n theta by n theta. Taking numerator limit sin m theta by n theta is 1, sin n theta by n theta is also 1 by limit theta tends to 0. By definition of the limit of sine function, you will get this is equal to m square by n square into this is 1 by 1. So this is 1 and limit theta tends to 0 sin n theta by n theta is also 1. So you will get m square by n square and it is given as 1 in the problem. The limit value is given as 1. So m square equal to n square. Therefore, m equal to, taking square root on both sides, you will get plus or minus m. That is your required answer. That's all about the problem. So, m square by n square is 1 given, the limit value is 1. Therefore, m square by n square equal to 1. Cross multiplying m square equal to n square and m equal to square, taking square root, you will get m equal to plus or minus m. That's all about the example. Okay, next problem. The next example in your textbook. Next example, example number 7.39. 7.39. Evaluate limit x tends to 0 plus, that means positive side of 0 limit. Limit approaches to 0 in the positive side. Limit x tends to 0 plus means limit approaches in the positive side 1 by e power x minus 1. We have to find out the limit value. If you apply the limit 1 by 0, infinity minus 1 by e power 0, 1, 1 minus 1 is 1, 1 by e power 0 is 1, 1 minus 1 is 0, 1 by 0, 1 by 0, infinity minus infinity. It is of the form infinity minus infinity form. If you apply x equal to 0, 1 by 0, infinity, e power 0, 1, 1 minus 1, 0, 1 by 0 is infinity minus infinity form. It's an indeterminate form. To find out the L'Hopital's rule, we have to convert this problem. Limit problem. You rewrite this problem taking x into e power x minus 1 as LCM. You will get 1 into e power x is e power x minus 1 minus x into 1 is x. So this problem becomes, if I take x e power x minus 1 as the LCM, e power x minus 1 minus of x into 1 is x. Now you apply the limit for x tends to 0, e power 0, 1, 1 minus 1, 0, minus 0, 0. Here it is of the form 0 by 0. If you put x equal to 0. It is also an indeterminate form. By L'Hopital's rule, you apply limit x tends to 0 plus L'Hopital's rule, e power x derivative is e power x, minus 1 derivative is 0, minus derivative of x is 1, by x into e power x minus 1 product rule, x into e power x minus 1, derivative of e power x minus 1 is e power x, plus e power x minus 1 you take it as common and derivative of x is 1. So this is the differentiation of the denominator. Product rule, x into derivative of e power x minus 1 is e power x. Derivative of 1 is 0, therefore you get x e power x. plus e power x minus 1 keeping constant derivative of x is 1. Now here also you apply the limit, you will get 0 by 0 form. Therefore again by L'Hopital's rule, limit x tends to 0 plus, again differentiating e power x is e power x by derivative 1 is 0. Product rule, x into e power x is x into e power x, derivative is e power x plus e power x into is e power x, derivative of x is 1 plus e power x derivative is e power x minus derivative of minus 1 is 0. X into e power x derivative is x e power x plus e power x. Again plus e power x derivative is e power x. Derivative 1 is 0. You will get limit x tends to 0 plus e power x by x e power x plus 2 e power x. Now you are applying the limit e power x derivative e power 0 by this is 0 plus 2 into e power 0 is 1, 2. So e power 0 is 1, 1 by 2. So answer for this problem is 1 by 2. That's all about the problem. So evaluation of this limit is 1 by 2. Next, another problem in the exercise. One more example we will see. You are applying L'Hopital's rule 2 times, 3 times even, and you will get the answer. Next example. Example 7.40, 7th chapter 40th example. Evaluate limit x tends to 0 plus x log x. If you apply the limit straight away, limit x tends to 0, positive side of 0, x is 0 into log 0. Log 0 is infinity, so it is of the form 0 into infinity, indeterminate form. Log 0 is infinity. So 0 into infinity form. To apply the L'Hopital's rule, you rewrite this problem x into log x by limit x tends to 0 plus, you keep log x as it is in the numerator and denominator, you bring this x to the denominator, it becomes 1 by x. X in the numerator is 1 by x in the denominator. Now you apply the L'Hopital's rule. This is log 0, infinity by infinity form. It is of the form infinity by infinity form. Log 0 infinity, 1 by 0 infinity. So it is an indeterminate form. For that you apply L'Hopital's rule. By applying L'Hopital's rule, log x derivative is 1 by x. By log x derivative is 1 by x. By derivative of 1 by x is minus 1 by x square. By simplifying, limit x tends to 0 plus 1 by x into x square minus 1 is minus x. 1 by x into minus x square by 1 is minus x. Applying limit x tends to 0, this is 0. Applying limit x tends to 0, you will get 0 only. So answer for this problem is 0. That's all about the problem. Example 40. Next we will pass on to a problem in the exercise. 9th problem in the exercise, 7.5. So that's all about the log value, limit of x log x is 0. Next, exercise problem 7.5. Exercise 7.5, 9th problem. These are very simple problems and are very easy to understand. L'Hopital's rules is nothing but you have to differentiate the numerator function and the denominator function separately, not applying quotient rule. You remember that. That is an important point. Numerator function, denominator function should be differentiated separately. Now exercise 7.5. Problem number 9. Evaluate a limit x tends to infinity limit extends to infinity 1 plus 1 by x power x. Limit extends to infinity 1 plus 1 by x power x. If you apply the limit straight away, limit extends to infinity 1 by infinity is 0, 0 plus 1 is 1. 1 power infinity, it is in indeterminate form. 1 power infinity is in indeterminate form. So, to apply the L'Hopital's rule, you take logarithm on both sides. You consider this function f of x by limit x tends to infinity 1 plus 1 by x power x. You consider this function by f of x. So, log of limit x tends to infinity f of x is equal to limit x tends to infinity log of 1 plus 1 by x power x. Taking logarithm, since the variable is in the power, you have to take logarithm on both sides. So this is equal to limit x tends to infinity, power x becomes new product x into log of 1 plus 1 by x, x into log of 1 plus 1 by x. Now this is again, you can rewrite as limit x tends to infinity log of 1 plus 1 by x by numerator x. You can write it as 1 by x in the denominator. If you apply the limit here also, you will get 0 by 0. In indeterminate form, you will get 0 by 0. If you apply the limit x tends to infinity, log 1 is 0, 1 by infinity is 0, 0 by 0. By L'Hopital's rule, to eliminate this indeterminate form, by L'Hopital's rule, log of 1 plus x is 1 by 1 plus 1 by x. Log of 1 plus 1 by x is 1 by 1 plus 1 by x into derivative of 1 by x is minus 1 by x square. This is the derivative of the numerator function. Log of x is 1 by x. So log of 1 plus 1 by x is 1 by 1 plus 1 by x into derivative of 1 by x is minus 1 by x square. And the denominator 1 by x derivative is minus 1 by x square. Denominator also, derivative of 1 by x is minus 1 by x square. You cancel minus 1 by x square both numerator and denominator. You will get simply limit x tends to infinity. You will get this cancel, you will get 1 by 1 plus 1 by x. Here a log of limit x tends to infinity f of x. So, applying limit x tends to infinity, 1 by infinity is 0, 1 plus 1 by n is 1. See, this is 1 by infinity 0, 1 plus 0 is 1, 1 by 1, that is equal to 1. So, log value is 1. So, limit value, 1 by infinity 0, 1 plus 0 is 1, 1 by 1 is 1. So, taking finding the limit value, eliminating log, taking e power exponential power on both sides, log of limit x tends to infinity f of x, e power log is e power 1. Taking e power exponential power on both sides, e power n is equal to e power log of limit x tends to infinity f of x. E power log is 1, therefore you will get only limit x tends to infinity f of x is a given function, e power 1 is e, therefore answer for this problem is e. So this can be expressed as limit x tends to infinity f of x is 1 plus 1 by x power x equal to, answer is e. That is your answer. Answer for this limit is e, exponentially e. That's all about the problem. Okay, this is problem, exercise problem 9 in the exercise. Next, one more problem in the exercise, 10th problem we will see. We will solve the problem number 10 in the exercise, limit x tends to pi by 2, okay. I will erase this, this is just taking exponential, to eliminate this log, taking exponential on both sides, e power log is 1, log e power log is function only, e power x, log of e power x is x. The condition is e power log x is x, this is your rule. Exponentiation logarithm cancelling, reciprocal functions, you will get only x. Therefore, e power log is limit only. E power log is limit extends to infinity f of x. That is the given function. It is equal to e power only e. Using this rule. Next, problem number 10 in the exercise. Problem 10 in the exercise. Limit x tends to pi by 2 sin x power tan x. Sin x power tan x. This is your problem. If you apply the limit x tends to pi by 2 sin 91 tan 90 infinity, it is 1 power infinity indeterminate form. This is 1 power infinity. Straight away if you apply, you will get an indeterminate form. For that, again taking logarithm, log of limit x tends to pi by 2 f of x is this problem sin x power tan x equal to log of, see this is again, this is equal to limit x tends to pi by 2 log of sin x tan x into log of sin x. So by taking logarithm, this tan x becomes power log sin x tan x into log of sin x. Tan x into log of sin x. So this is equal to limit x tends to pi by 2 log sin x you keep in the numerator, and tan x if you bring into the denominator it becomes cot x. Tan x if you bring into the denominator it becomes cot x. 1 by tan x is cot x. Now apply this is applying limit sin 90 log 1 0 cot 90 0 0 by 0 indeterminate form again you will get. So to apply the L'Hopital's rule, limit x tends to pi by 2 log sin x derivative is 1 by sin x into derivative of sin x is cos x by derivative of cot x is minus cosecant square x minus cosecant square x. So 1 by cosecant square is sin square. So this is, it becomes limit x tends to pi by 2 limit x tends to pi by 2 1 by sin x into minus sin, it becomes 1 by cosecant square is sin square in the numerator. Cosecant square is sin square 1 minus 1 by sin x into cosecant square is sin square x into cos x. So you will get limit x tends to pi by 2 minus sin x into cos x. This is your limit. Minus sin x, sin square will cancel, minus sin x into cos x, limit x tends to pi by 2, sin 90 1, cos 90 0, 0 into 1, 0 into 1, cos 90 0, 0 into minus 1 is 0. So answer is 0. Because sin 90 1, cos 90 0, 0 into minus 1 is 0. So log of limit x tends to pi by sin power x by tan x is 0. Now taking a e power log on both sides, exponential logarithm, applying this step, you will get see by taking logarithm e power log of limit x tends to pi by 2 sin x power tan x sin x power tan x is equal to e power 0. What is e power 0? 1. So this is again just simple. The problem becomes e power log is problem only. That is e power log cancelling, you will get limit x tends to pi by 2 sin x power tan x is equal to e power 0 1. So the problem answer for this problem is e power 0, which is 1. That's all about the problem. Tan x. So answer is 1. So taking exponential on both sides, e power log of the problem is problem itself and e power 0 is 1, therefore answer is 1. That's all about the problem. So thereby I conclude the exercise and I conclude the video also. We will continue our next topic in the next video. Thank you.